All right, guys, happy Friday. We're going to start our next unit, which is going to be on polar coordinates. So today we're just kind of introing into what a polar coordinate is. And then your homework will be on Delta Math as per the usual. Okay. So the Cartesian coordinate system is the type of mapping that you already know how to do. So you're going to have an X and a Y. And then both the X and the Y are directional. So it's either plus or minus. Okay, your horizontal and vertical components are both going to be measured from the origin. So if I wanted to graph, let's say 2, 6, I would go to 2 on the X, 6 on the Y, place my dot. Next one is -1, 3. So I'd go to -1, 3 on the Y, place my dot. Okay, so this is the type of graphing you've already done for forever, right? 0, -4, I'd go to 0 on the X, -4 on the Y, I'd place my dot. Okay, this was 2, 6. This was -1, 3. Okay, next point is 5, 0. So I'd go to 5 on the X, 0 on the Y. That'd be 5, 0. And then one more point is 7, -2. So I'll go to 7 on the X, -2 on the Y, place my dot. Okay, so today we're going to talk about a different form of mapping points. So rather than you using an X and a Y, you're going to use an R and a theta. Okay, the R is going to be a directional radius, and it is still measured from the origin. And then the angle is going to be your theta. Okay, and the good thing is that it's still going to be measured from the exact same place it was measured from on the circle. So this is going to be your radius. This is going to be your direction. Okay, so let me show you what I mean by that. Rather than having an XY grid like this, for polars, you're going to have a grid that looks like this. So what you're going to do is you're going to trace out to the R or ring that you want to be on, and then you're going to rotate around to the degrees that you want to be on. So here's what I mean by that. Okay, if I'm doing 3, 30, okay, remember I always start here. Okay, this is the place we always rotate from. I'm going to count out to the third ring. So that'd be 1, 2, 3. This is R3. And then I'm going to rotate to where 30 degrees is, and I'm going to place my dot. So that would be point to R. Okay. All right, next point, I want to be on the 5th ring, and I want to be on 120 degrees. So this would be 1, 2, ring 3, ring 4, ring 5. But then I need to rotate around to 120 degrees. So that would be all the way to here. And that would be point S. Jackson, are you doing test correction? Okay, cool. All right, so we've done the first two. Let's go on to the next one. So I want -4, 120. So if I have a negative radius, okay, essentially what's going to happen is you're going to still go to the degrees that you want. So like 120 is still here. But rather than you counting your 5 rings towards that angle, you're essentially going to count those rings away from that angle. So if my 120 is here, those would be my positive R's. Then my negative R's would be me tracing back 4 rings. So 1, 2, 3, 4. So that would put me here. So that would be my T. Okay. All right, next one is -4, 150. So I want to be on the -4 ring at theta 150. So I'm going to find 150. 150 is here. And if it's a positive ring, I would go towards the angle. But because my ring is a -4, I'm going to actually count the opposite direction. So just kind of trace that away. I want to go 1, 2, 3, 4. That would put me right here. So that would be my U. And so even though these come in the order that you get the ring first and the theta second, to me, it's easier to find the theta on the circle first and then count the ring second. But you just have to know they're going to come ring first, theta second. Okay, next one says, I want -3, 60. So let's find our 60 degrees. 60 degrees is here. But then because my radius or my ring is a -3, instead of going towards the 60, I'm going to trace away from the 60. So I'm going to go back. My ring is -3. So 1, 2, 3 puts me right here. Now it says, what is that point the same as if I use a positive radius? Okay, well, this point right here, which is V, okay, it could also be mapped using a positive radius as long as I adjust my degrees. So if I want my ring to be the positive third ring, then it would be the same as me counting towards 240 degrees. And so what you'll notice is that because we're using a circular map, you can still end up with angles and radiuses that put you in the same spot. Remember, that's called coterminal, where you end in the exact same spot. End in same position. Okay, next one, I want 5, -30. Okay, well, you should know that if 30 degrees, you rotate up 30, then -30 would put you on this angle right here. Okay, that instead of me going 1 click up for 30 degrees, I would go 1 click down. Okay, so that would put me here. And then I want to go out to the 5th ring. That'd be 1, 2, 3, 4, 5 would put me right here. This would be W. Okay, I could also list that as 5, 330. Okay, because I know that whether I go 30 this way or -30 this way, that's the same as 330 this way. Okay, one more. We have 2, -60. Well, -60 would be 3 clicks up. Watch, I'd go 1, 2, 3 to get to 60. Well, then rather than me rotating 60 up, I would rotate 60 down. That would put me at 300. And then I want to end up on the 2nd ring. So I would go out 1, 2, that would be this point right here for my X. And then if I wanted to count that out without any negatives, I would say I'm on the 2nd ring for 300 degrees. Okay. And this is going to be different. All right, go ahead and turn the page. On the next page, we're going to basically do the same thing, but rather than measuring all of our angles in degrees, we're going to measure them in radians. So you'll notice that your circle's almost the same, but rather than having degrees around the edge, you have radians. So if I want 5, pi thirds, remember it's the radius first, the theta second. Okay, then I'm going to find the pi thirds angle. That's this one. And then I'm going to count out to the 5th ring. So it would be 1, 2, 3, 4, 5. That makes this point A. Next one, I want 7, pi 6, 4. So I'm going to identify where my 7, pi 6 is. It's here. And then I'm going to count out to the ray that I want to be on. I want to be on the 4th ray. So that would be 1, 2, 3, 4. And I actually meant to say the 4th ring. Okay. Next one, I want pi halves, -5, pi halves. Well, pi halves is normally straight up. But in this case, because I have a negative radius or ring, instead of me going 5 towards the pi halves, I'm going to count 5 away. So it'd be 1, 2, 3, 4, 5. that would place my dot C here. Okay, my next one is 7 pi-4 and a -3. So I'm going to find my 7 pi-4 angle. 7 pi-4 is right here. But then because I noticed that my ring is really a -3, instead of me going this way towards the angle, I'm going to trace the opposite way 3 rings. So I would go back 1, 2, 3. So that would put me right here. And this would be D. Now it says, what point is that the same as? Well, then I would want to think about it. If I want to end up here, I'm on the 3rd ring if I'm counting towards 3 pi-4. Oh, wait, that's this one, sorry. I'm on the 3rd ring if I count towards 3 pi-4.
Yeah, this one's gonna be weird.
Okay, now let's say we want to do the same thing for C. Okay, remember I went to pi halves, but then I counted away. Well, then if I want to use a +5 for my radius, then I would need to make sure that I'm counting towards 3 pi halves. Okay.
Okay, yeah, those are just a little like ball.
All right, next one is point E. I have a -2 radius at pi for my angle. So I'm going to find pi for my theta. Pi is straight to the side. But then because my radius is a -2, instead of me counting 2 rings towards it this way, I'm going to count 2 rings this way. So this would be my. And then I would say, okay, well then if I want to rewrite this with positive radius and theta, then I'd be on the 2nd ring if I'm counting towards 0. Now, technically 0 and 2 pi are the exact same position. So if you wanted to put 2, 2 pi, that would be even a 3rd way for you to end up in that same position. Okay, last one like that. I want to be on the 4th ring of -pi6. Well, if pi6 is 1 turn up, then I want to go 1 turn down, which puts me on 11 pi6. And then I would want to be still on the 4th ring. So that would be 1, 2, 3, 4 would put me here for point. Okay. So it's a little bit weird, but for the first part of the homework, you're just placing points. So make sure you're on the correct angle. And then for positive R's, you count towards the angle. Negative R's, you're going to count away from that angle. Okay. All right, next one. You have a grid and you're going to be writing the points 2 different ways. Okay, so for the first one, you can use both positives. And then when you write it the second time, you can use either a negative radius or you can use a negative angle. So let's say I'm doing point P. Okay, so the first thing that I would notice is, okay, well, how many rings am I out from the center? So I notice that I'm out 1, 2. So my radius is a 2, comma. And then I need to know what angle I'm on. Now, you'll notice that on this unit circle, this middle angle is missing. Okay, but if you look on the one right above it, between 2 pi-3 and 5 pi-6, okay, I can see that it's a 3 pi-4 missing in the middle. So if you want to just label that in here, this is a 3 pi-4. Okay. And then if I wanted to use a -2 for my radius, then I would think about, okay, well, then I need it to be away, which means I would need to be tracing towards this angle. And then if I kind of look at that unit circle above it, that's totally filled in, I know that that middle angle here should be a 7 pi-4. So if I list 7 pi-4 as my angle, then I can see that I'd be tracing 2 away from it. That would still map me at P. Okay, remember, those are called coterminal. Okay, letter Q, I see it down here. Well, one way I could do it is 1, 2, 3 rings towards 5 pi thirds. Okay, or I could measure it using a negative angle or a negative radius. Now, I will say I think measuring with a negative radius is easier. So if this is 5 pi thirds, then the other half of that, if I just kind of trace backwards, would be 2 pi thirds. So I'm going to switch my R to be a -3, and I'll use 2 pi thirds as my angle. So that I'd find 2 pi thirds, and then instead of counting towards it, I'd count away 3 radius to get to the Q. Okay. All right, you have one more left. Go ahead and give it a try. Okay, I see that I'm on the first ring on the 4 pi thirds angle. Well, then if I want to use a negative R, I would just need to kind of trace through the circle the other way. So if I trace through the other way, I'd be going this way into pi thirds. So if I use a -1, pi thirds would be my angle. Okay, but it's just a different system of mapping. And you're going to use the ring or radius and then the theta. Okay, last little bit of this. Go ahead and turn the page. You're almost done. Okay, we are going to practice converting from polar coordinates into Cartesian coordinates. So if you turn the page, okay, we have 3 points that are listed right now as polars. So that's an R, theta. So what we're going to do first is we're going to map each of these points onto the polar grid down here at the bottom. So I have a 4, 3 pi fourths, and that's point A. So I'm going to find 3 pi fourths is here. And then I want to go to the 4th ring from the center. So 1, 2, 3, 4, that puts me here. This is point A. All right, next one. I want to do -4, pi thirds. But I'm going to find my pi thirds angle that's here. And then rather than me counting towards the pi thirds, I'm going to count 4 rings away. Now, if you kind of trace, okay, pi thirds is going to end up tracing onto 4 pi thirds when you go the other direction. So if this is pi thirds, instead of counting towards it, I'm going away. 1, 2, 3. That would be point B. Okay, then we have one more left. Point C is 2, negative pi thirds. Well, pi thirds is 3 up. So I'd go like 1, 2, 3. Then I want to count 3 down. So that would put me on 5 pi thirds. And then I see that I want to be on the 2nd ring. So I would go 2 rings towards that. That would put me right here. Okay, so now our goal is to take those R, theta points, and we want to turn them into X, Y points. Okay, and the nice thing about this is that it's very similar to the unit we just finished on vectors. So what you're going to do is you're going to do your X equals, look up here at the top of your paper, the formulas are already written for you. X is R cosine theta. Oh, and this should say Y is R sine theta. So my X coordinate is going to be R is a 4 cosine 3 pi fourths.
Okay, I mean, I'm not.
And then my Y is going to be a 4 sine 3 pi fourths. Now you have this little tiny unit circle. If you have your old unit circle, you're welcome to use that, but we're going to pull these values off of that unit circle. So if I'm looking for the cosine of 3 pi fourths, I know it's been a while since we did this, but you would find 3 pi fourths on the circle. And then remember, cosine is the X value and sine is the Y value.
Yeah.
So if I'm looking for cosine 3 pi-4, 3 pi-4 is here. My cosine is a negative root 2 over 2. And then I would multiply that with the 4 that was already in front. Now, because the 4 and the 2, okay, these are both just regular numbers, I can go ahead and like divide those with each other. So this is a negative 4 on top divided by a 2 on bottom. That gives me a negative 2 root 2.
Oh, wow.
Now remember, that's my x. Now I need to find my y. So I'm going to go back to 3 pi-4. 3 pi-4 is still here.
Yeah.
But for sine, I want the y value. And notice that my y value here is a positive root 2 over 2. So it's going to be 4 times root 2 over 2. And then I notice that this 4 and this 2, they're both just regular numbers on the outside. That means I can divide them. So 4 divided by 2 is going to be 2 root 2. So let's rewrite our point A as an x comma y. Point A would be negative 2 root 2, comma 2 root 2. Now, it's going to be pretty hard for me to graph it in that form. So I'm going to use my calculator to turn both of those into decimals. So negative 2 square root 2 is negative 2.8. And then the y would just be the same thing, but positive. So then I'm going to take that point, place it on my XY grid, and they should end up in the same place. So let's see. I'm going to go to the left 2.8. So that's 1, 2, we'll say 0.8. And then I'm going to go up 1, 2.8. That puts my point A in literally the exact same position that it was in when I mapped it in polar. So this is polar r theta, this is polar xy, but you can see from the graphs that they ended up basically in the exact same position. All right, let's do number 5. Okay, number 5, I know that my x needs to be r cosine theta, my y needs to be r sine theta. So my x is going to be negative 4 cosine pi-3, and my y is going to be negative 4 sine pi-3. Then remember, I'm going to pull these values off of my unit circle. So find your pi-3 here. Pi-3 is right here. I see that my x is a 1/2. So this is going to be negative 4 times a half. And my y is a root 3 over 2. So that'd be negative 4 times root 3 over 2. Okay, then looking at my x, if it's negative 4 cut in half, that'd just be a negative 2. For this one, my negative 4 divided by 2 gives me a negative 2. And then remember that the root 3, you really can't do anything with that. You're just going to kind of leave it. So your ordered pair is going to be for point B, negative 2, comma, negative 2 root 3. And then in order for me to place it on here, I'm just going to turn that negative 2 root 3 into a decimal. So it's going to be negative 2, comma, negative 2 square root 3. That gives me negative 3 point, we'll round that off to a 5, even though it's really a 0.46. So now let's see if it ends up in the exact same spot. So I'd go to the left 2. My y is a negative 3.5, so 1, 2, 3.5. That puts me right here for point B. And then when I look at the positions, I see that they end up in the exact same place. So this and this map me to the exact same position. Okay?
All
right, last one, point C. So for point C,
well, this is my job.
we have r of theta and a negative pi-3 for my, or sorry, my r is a 2, my theta is a negative pi thirds. So I'm gonna put x equals, remember the radius goes in front, cosine negative pi thirds. And then sine negative pi thirds.
You can think of one.
Okay, then I'm gonna pull these two values off of my circle.
No, I mean, oh, you got.
Now remember, pi thirds is if I rotate up. Okay, I would say that's 3 turns that I'd go 1, 2, 3. So I want to rotate down 1, 2, 3. That puts me at 300 degrees. And then remember, the x is going to replace my cosine. The y is going to replace my sine. So I see here that my x is a half. That'd be 2 times a half. My y is a negative root 3 over 2. And then if I simplify those, half of 2 is a 1. And then on this one, those 2's are going to cross out and just leave me with a negative root 3. So my ordered pair for point C is going to be 1 comma negative root 3. Now, if I'm trying to place that on my graph, I'm going to run into the same issue that I don't really know what negative root 3 is. So I'm going to put it into the calculator. So the negative square root of 3 is about negative 1.7. So then I'll go over 1, down 1.7. That puts me here for point C. And then I look at my original work and I see, wowie, those mapped to the exact same spot. Okay, you love it. You're so excited. All right, guys, so you are now going to transition to completing your homework on Delta Math. If it's a problem set, remember, it'll just give you new ones. The one thing I do want to say is that when you're converting at the end, and it's like questions like this, you need to type in the answer before you put it in the calculator. So what I mean by that is like for C, your answer would be 1 comma negative root 3. You would not type this into Delta Math. For B, you would type in this as your answer. Okay, you would not type in the rounded version. Okay, and then for the first one, for A, you would have typed in this. Okay, but you have to use your unit circle on that. Hopefully you still have yours from that unit. Okay, if not, you have a little baby one right here. Okay, happy Friday. Have a good weekend.